Wide Area Network (WAN). Think of a wide area network, or WAN, as the massive digital highway system that connects isolated islands of data together, while your LAN is the private road inside your own property. The WAN is the sprawling public interstate that allows data to travel across the state, across the country, or around the world. As you master these concepts for your CompTIA A+ exam and look ahead to your CIS classes at BCC this fall, understanding the WAN is critical. It is the fundamental architecture that allows your local home lab in NYC to securely communicate with a distant cybersecurity target server halfway across the globe. The geographic boundary, crossing the map. The defining characteristic of a WAN is its massive geographic scope. A WAN exists specifically to connect multiple, geographically separated local area networks together. The most famous and massive example of a WAN is the Internet itself, but WNS are also heavily used in the enterprise world. If a corporate business has a headquarters in New York City and a branch office in Los Angeles, the network that connects those two distant buildings together into one cohesive system is a WAN. The principle of ownership, the leased line. When we contrast a WAN with a LAN, the most important difference is ownership. As we discussed, you own the cables and switches inside your LAN, but you do not own the thousands of miles of fiber optic cables buried across the United States. To build a WAN, you must lease a connection from a telecommunications provider or an ISP, an internet service provider. Because you are using someone else's infrastructure, you have to pay for the privilege. This is why you pay a monthly subscription fee for your internet, or why a large corporation pays tens of thousands of dollars a month for a dedicated enterprise fiber link between their offices. The hardware, the domain of the routers. While the switch is the king of the LAN, the router is the undisputed king of the WAN. Switches use physical MAC addresses to move data inside a single room, but MAC addresses cannot cross the internet. To navigate the WAN, your data must be packaged into packets with logical IP addresses. When data needs to leave your house, it is sent to the default gateway, which is your local router. That router acts as the border guard, stripping off the local LAN information and shooting the packet out across the WAN to be handed from one provider's router to the next until it reaches its destination. Modern implementations, SD-WAN and VPNs. In the modern cybersecurity landscape, sending raw data across the public internet is dangerous because you do not own the WAN cables. Anyone sitting on the provider's network could potentially intercept your traffic. To secure a WAN, professionals use site-to-site VPNs, or virtual private networks. This creates a heavily encrypted tunnel right through the middle of the public WAN. A newer, highly testable concept for your certification is SD-WAN, or Software-Defined Wide Area Network. This technology uses software to automatically route traffic over the absolute best available path. Whether that is a dedicated fiber line, a standard broadband connection, or even a 4G LTE cellular backup, ensuring maximum speed and uptime for the business. Contrast and comparison for the A+ exam. To lock this in for the exam, remember these stark contrasts. WAN versus LAN, geography. A LAN is a single building or campus. A WAN spans cities, countries, or continents. WAN versus LAN, ownership. You own a LAN, you lease a WAN from a service provider. WAN versus LAN, speed. Because of the massive physical distances and shared infrastructure. A WAN is generally slower and has much higher latency than a gigabit LAN. Moving a 1 terabyte file across your desk takes minutes. Moving it across a WAN could take hours or days. By mastering the transition from the privately owned LAN to the vast, provider-owned WAN, You understand exactly how data makes the leap from your local machine to the global stage.